When we look at a graph, remember a graph is a set of points that solve an equation. So here I have a graph of a parabola, a quadratic equation. And when we look at that graph, we can tell immediately if we have a function or not by using the vertical line test. So what I mean by that is if we take a vertical line, like this blue line that I have here, this dotted blue line, and I hold that vertically like a pen or pencil, you can do this with me, then when I go across the graph of the parabola from left to right, the blue line should intersect with the parabola at only one point at a time. So you can see they intersect here, and that point will move gradually along that parabola. Now, because the point only intersects the parabola at one point at a time, then this passes a vertical line test. An example of a graph that would not is here. So this is also a parabola, but this parabola is not a function. So the other was a quadratic equation in terms of x. This is a quadratic in terms of y. So the dependent variable here is not linear. And this does not pass the vertical line test. You can see that it intersects the graph in two places. So for the x value, 3.5, it corresponds to two different y values. That means that it is not a function. Another concept that I mentioned, something that we discussed, is that of a one-to-one function. Now, if I graph y equals x to the third degree, this function does pass the vertical line test. Also, it would pass a horizontal line test. So a horizontal line test, I'll take a horizontal line, and you'll notice that this graph passes the horizontal line test. It looks close right here. I realize that it does look close, but if you zoom in very, very close, then you'll notice that that line does touch that only once. And I also know that from calculus. So this graph is a one-to-one function. It passes the vertical line test and the horizontal line test.